Okay, we are moving on, discussing our parabolas and graphing. We talked about critical points the other day, a little reminder. Remember, there is a maximum of 4 of them. Okay, hopefully you remember them all. First, we deal with the vertex, that's a huge one. Then you have the y-intercept, and you have the solutions, which is also called the x-intercepts or zeros. Now remember that with the solutions, you often have 2, but you could have 2, 1, or none. Which means, maximum critical points is 4, but you could have just 3 or 2, depending on the problem. All right, now let's just do a little sketch. Okay, there is a parabola. Of course, down here, whoops, color didn't change. Down here, that is the vertex. And this thing here is the y-intercept. And these 2 things here, of course, in blue would be the solutions. And this isn't really part of the parabola, but we talked about this the other day. This thing here is called the axis of symmetry. Okay. All right. Now, down here, we're going to talk, it says, what does the A value tell us about a parabola? So let's, in a quadratic equation, we're typically, this is standard form, ax squared plus bx plus c. And if you remember, in standard form, this number, this constant c hanging off the back, that's your y-intercept. Okay, what we're going to examine now is this number in front. If there's nothing that, sometimes it's an invisible 1, but we're going to talk about this a value. What does it tell you about the parabola? And I'm going to try to show you this during the live Zoom lesson. Remember, this will be on Thursday, May 7th at 1:30. Hopefully I can show you anyway on the Inspire. See if I can do that remotely. I'm not too sure how well it will go. But I'm just going to summarize it here. This a value, the farther, first of all, if a is positive, the parabola will open upwards. Okay, and if it opens upwards, that means the vertex of the parabola is called a minimum, because the vertex is at the absolute bottom. And I'm sure you can guess, if a is negative, the parabola will open down. In that situation, if the parabola opens down, that means the vertex is considered a maximum because it's at the top of your parabola. Okay. Now, as the absolute value of a gets larger, the parabola gets steeper / narrower. Okay. And as the absolute value of A gets smaller, the parabola gets wider. Okay? Now, what does that mean? Well, I'll give you a couple of examples here. Let's just say, let me just do a little sketch. Okay. Let's say we have our baseline of y equals x squared. Now, there's the a value here would be this invisible 1. And let's just say it gives us a parabola like this. Okay? So that has an a value of invisible 1. Now, if we had, I'm just doing some rough sketches here, folks. Let's say we had something y equals 3x squared. So you see here the a value is getting larger. That means your parabola is going to get steeper. It's going to be something like this. Okay? I'm just doing a very rough thing here. And then in orange, let's say we have 1/2 x squared. Well, you see that's a smaller than the black one. So this would be even wider. It would be something like this. Okay? And then you can picture, it would be even wider if this was like 1/4 or 1/10. So that's kind of what I'm talking about when I say wider or narrower, if you use the black one there as a baseline. All right, we got some huge stuff here we're going to do now. So we're going to start graphing this stuff. Now, take a look at this next page. First of all, there's some things that we can tell right away. This is written in standard form. And right away, we see that the a value is -1. So we know that this thing is going to open down. Okay? Also, it's in standard form. So this number written off the back, that is the y-intercept. So we know it's going to go through 1, 2, 3, 4, 5, that point. Okay, so those two things, when it's in standard form, whether it opens up or down, and what the y-intercept is, we can determine right away. All right. Now what we're going to do is something new. We want to find the vertex. Now it's not in vertex form. It's in standard form. Okay? It's in standard form. When you're in standard form, here's a new formula we're going to write down. We're going to put a big box around this. The x-coordinate of your vertex is the opposite of b over 2a. Okay? X-coordinate of your vertex. Remember, the vertex is two things. It's an x comma y. We'll talk about y in a moment. So for this one, we would write down our a. Remember, our a was -1, our b was -6, and our c was -5. So the x value of the vertex would be opposite of b over 2 times a, and that comes out to 6 over -2, which is just -3. Now remember, that is just the x value of the vertex. We need the y value as well. Now, how do you get the y value? I'm going to write that down. Okay, the y value comes from plugging the x value into the equation. Okay, so we know our x value is -3. Now you can use your calculator to help you with this, but you got to be careful even just plugging this in. So I'm just rewriting the initial equation. Remember, it said negative. That negative sign is still there. The only thing that was getting squared was the x. All right, so now, we're going to take that -3 and replace it. Replace the x with that. -6, plug in the -3 for x, -5. Now you got to be careful with this. You got to do PEMDAS. -3 squared would be 9, and 9 times -1 would be -9. Negative times a negative is positive. So negative, you get, this comes out to what? It comes out to 4. So our vertex is -3, comma 4. All right. So we now have 2 of our critical points, right? We had the y-intercept. We had that right away. Now -3, comma 4. 1, 2, 3, 1, 2, 3, 4 is right up there. Now we want, well, we're going to have to do some solving in a second. Oh, axis of symmetry, we can do that. Remember, we're looking for an equation. It's always x equals, because axis of symmetry is always a vertical line, and it's always x equals whatever the x value of the vertex is. In this case, -3. Okay, the zeros. So remember, we've been doing this for a long time now. Zeros means you're solving. So replace the y with 0. And, I don't like that leading coefficient to be negative. So let's go ahead and multiply both sides by -1. So now the signs all change here on the right. Okay, we can factor this. Whoops, that should say squared. Sorry about that. X times x, 5 times 1. Everything is positive. So our answers are -1 and -5. Remember, those are the x-intercepts. So I'm going to go back up to my graph now. I'm going to go back up to the graph. And I'm going to go to the -1 and -5. And there are my 4 critical points. Now remember, because of symmetry, well, here, I'm going to draw the axis of symmetry. Remember, it goes straight down through the vertex. Now, because of symmetry, a lot of times you're asked to graph with like 5 points. Now, you have 4 critical points, but remember, there's a twin point to the left of this one. You see, how far is this thing from the axis of symmetry? It is 1, 2, 3. That means there's a twin 1, 2, 3 right there. And now we're going to draw a nice curve. And there is our parabola. Shazam! Okay. Shazam. Probably should do a couple more of these anyway, right? Here's another one. Again, right away, look at this. An A is invisible. It's an invisible 1. It's positive. So that means it opens up. And the y-intercept is this number here. So those 2 things we can determine right away. All right? Right away. I just noticed something on my key isn't quite right, but anyway. So let's take a look here. Define the vertex. Remember, that is opposite b over 2a for the x. So the opposite of b would be -8 over 2 times 1, and that'll come out to -4. Okay. Now, that is just the x value of the vertex. To get the y value, take that -4 and plug it into the equation. Y equals, you square the x, plug in the -4 there, Okay, this should come out to 16 minus 32 plus 12. And that is going to be, that's going to be -4 as well. So our vertex is actually -4, comma, -4. So we know two of the critical points now. We know the y-intercept is 0, comma, 12. And we know that the vertex is -4, -4. So let's go down to our graph. And let's go ahead and put some of it on there. So 1, 2, 3, 4, 1, 2, 3, 4. There's the vertex. Now my y-intercept is going to be a little bit off the graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's going to be about right there. So we still need to solve. We'll do that in a moment. Remember our axis of symmetry. That is x equals -4 because that's what the x value is. The zeros we are going to replace. I'll do this in blue actually. The zeros, we replace the y value with 0. And we have x squared plus 8x plus 12. And we are solving now. It looks like we could probably factor this. 6 and 2, plus and plus. X equals -6, x equals -2. Those are the x-intercepts. All right. So what does that say? It says 6 and -2. There's the -2. There's the negatives. Whoops, I miscounted there. There's the -6. Now remember, if you want to show a fifth point, you would have a twin to this. So let's put the axis of symmetry in here. That's going to be the vertical line right through here. Now, maybe the easiest way to get the twin to this y-intercept is, this is 1, 2, 3, 4 units over. So we go 1, 2, 3, 4 units that way. And now this parabola is kind of spread out here, but draw a nice curve. We're all set. Okay. Let's try, whoops, scrolled a little bit too far there. Let's try B. Again, invisible 1, positive, opens up. Y-intercept. Okay, vertex, opposite B over 2 times A. That comes out to just 1. I can probably figure this out in my head. If I plug 1 in here, I get 1 minus 2 is -1. -1 minus 3 is -4. There's my vertex. So that means my axis of symmetry is x equals 1. So I got 2 of my critical points. I'm going to do the zeros right now, and I'll plot all the points here in a second. So I get x squared minus 2x minus 3. I think this one will, that's not always going to factor. Sometimes you're going to have to use quadratic formula. Just so you know, I get x equals -1 and x equals 3. Those are my x-intercepts. So here we go. 3 and -1 are my x-intercept. There's the -1. There's the 3. Okay. My vertex was what? 1, 2, 3, 4, -4. I have a y-intercept of -3, which means my fifth point would be right there. There you go. You could draw on the axis of symmetry if you want, right down through there. Not required or anything. Okay, so still got couple more pages to look at, actually. But I'm not gonna do all of it here in this lesson. Hold on. Let's go to the next page. I'm gonna give you an opportunity. You can do C yourself. Now remember, I post all the answers to these lessons on the Canvas homepage. You can print these all out. So you can do C yourself. It works out nicely. You can factor it for the zeros. There's nothing that's really different here. So you can do it and check your answers there. We're going to do D together right now because D is a little bit different. You see how it looks a little bit different? Still standard form. A is negative, so it opens down. Y-intercept is this plain number here, 0, 9. So that's not anything new. Now the vertex, this is easy as well. Now, I hope you guys realize in this problem, A is -1. B, there is no x term. That means B is 0. Okay? So if I do opposite B is, opposite B, opposite of 0 is, of course, still 0 over 2 times -1. Well, 0 over anything is just 0. And you can just do this in your head. Obviously, if you plug 0 in here, this all becomes 0 and plus 9. So, you know, it turns out here that this is our vertex. And our vertex turns out to be the same as the y-intercept. That happens sometimes. So that we have the same coordinate for two different critical points. Okay? Axis of symmetry, of course, is going to be x equals 0. Let's go ahead and find the zeros here, and then we'll do the graph. So 0 equals -x squared. Now remember, there's no b term here. So we can actually solve this using the square root method. Get x squared by itself. I'm going to move the -x squared over here by adding it. So I get x squared equals 9. Take the square root, and I get positive or -3. There's positive 3. There's -3. Okay, those are the two solutions. Now remember, our y-intercept and the vertex was the same thing. It was at 0, 9. So that's going to be right up here. Why is that not changing? There we go. So we actually only have 3 critical points here. That's okay. We can handle that. And if you were to draw the axis of symmetry, that would be right on top of the y-axis, right? It would be boom, boom, just right there, right? Now, folks, I know I'm going kind of fast here, but remember, we're going to do a live lesson where you can ask questions. We'll go as slow as we need to. This is on Thursday, May 7th at 1:30. Okay. I'm going to wrap this lesson up, this version of the lesson up here in just a moment. There's a little bit of matching on the back. It doesn't take long. I'm just going to talk about it. I'm going to talk about my thinking here. So look, this is all based on the A value. Remember, if it's positive, it has to open up. So 1 and 3 have A values that are positive. So they're the ones that have to open up. 2 and 4 have A values that are negative, so they would have to open down. Remember, the further A is away from 0, the steeper the graph gets. So let's look at the two that open up. This is really a lot farther away from 0 than 1/4. So the 1/4 is going to be the wider one, and this is going to be the narrower one. So the ones that open up are A and B. So this one would be A, and this one would be B. Okay. Here, these both open down. This one is farther away from 0, so that means it's going to be steeper. So that's going to be the C one, and this would be the wider one, the D one. All right? So Let's be there. Meet up for the lesson on the 7th. Hope you guys are doing well. Don't forget about office hours every blue day at 1 o'clock for half an hour before the lesson. There's also opportunities for you to Zoom and get help through the AAC every single day. That information is on the Canvas homepage as well. See you later.